Good day, students. So today we'll be discussing on your fourth experiment in System Software and Compiler Lab. Your fourth experiment will be on token separation using LEX. Okay, so we'll discuss about LEX and how to implement it and so on. Okay, so this is your overview. It will have the objective of what you're going to achieve at the end of the session, description on introduction on LEX source, and a sample input and output. So the objective here would be to write a LEX specification for token separation using regular expressions. Okay, so let's just start with the description on introduction on LEX and what LEX sources and so on. Okay, so coming to this part. Okay, so LEX source here. What is a LEX source? As in, it is a table of regular expressions. Okay, regular expressions and corresponding program fragments. So the table, what this table does is that this table would translate this table would translate to a program that reads an input stream. Okay, and it would copy it to an output stream, and it would partition the input into strings which will match the given expressions. Okay, this is what happens in this LEX source. Okay, and this is what happens within the table. Okay, so as each such strings are recognized, the corresponding program fragment will be executed. So the recognition of the expressions are performed by a deterministic finite automation, okay, which is generated by LEX. Okay, so using LEX, and the program fragments which are written by the user are executed in the order in which the corresponding regular expressions occur in the input stream. Okay, so basically they are executed in the order which are given inside the input stream. Okay, so and later what happens with the lexical analysis programs which are written is that, so the lexical analysis programs written with LEX would accept ambiguous specifications, and it would choose the longest match possible at each input point. Okay, so and if necessary, the substantial look ahead will be performed on the input. Okay, but the input stream will be backed up at the end. Okay, it will be backed up at the end of the current partition. Okay, why as in, so that the user has general freedom to manipulate it. Okay, so here LEX is a program generator. Okay, so what is it used for here? It is used for designing for lexical processing of character input streams. So here it accepts a high level problem oriented specification for character string matching, and it also produces a program as a general purpose for a general purpose language, okay, which recognizes regular expressions. Okay, so here the regular expressions are specified by the user, okay, in the source specifications which are given to LEX. So what happens here is that the LEX written code will recognize these expressions in the input stream and partitions the input stream into strings matching the expression. Okay, so at the boundaries, what happens at the boundaries is that at the boundaries between the string program sections which are provided by the users are executed. Okay, so the LEX source file. Okay, so what happens is that the LEX source file will associate the regular expressions and the program fragments. Okay, so as each expression appears in the input to the program, which is written by LEX, the corresponding fragment will be executed. So, and also that the thing is, LEX is not a complete language, okay, but rather it is a generator representing a new language feature, okay, which can be added to different programming languages. which is called as host languages. Okay, so just like any general purpose language can produce code to run on different computer hardwares, this Linux can write code in different host languages. Okay, so the host language is used for the output code generated by Lex, and it is also for the program fragments, okay, that are added by the user. Okay, so the compatible runtime libraries for the different host languages are also provided. Okay, so this makes what happens because of this is that this makes Lex more adaptable. Okay, so different environments and also to different users. So here each application may be directed to the combination of hardware and host language which is appropriated to the task. According to the task, the combination of hardware and the host language could be selected. Okay, so the users and also the user's background and the properties of local implementations can also be chosen based on that. So here we have several tools. Okay, so several tools are built for constructing lexical analyzers from special purpose notation. Okay, they are based on regular expressions. Okay, so Lex is basically a widely used tool to specify lexical analyzers for a variety of languages. So we refer to the tool as the Lex compiler, okay, and to its input specification as the Lex language. Okay, we refer the tool as the Lex compiler and the input specification as the Lex language. Okay, so here Lex is generally used like I'll just show you the figure. Okay, so here you're able to look at the figure, right? So here Lex is generally this is how it is depicted. Okay, so first a specification of a lexical analyzer prepared by creating a program named Lex1 in the Lex language. Okay, this Lex1 is run through the Lex compiler to produce a C program. Okay, which is Lex YYC. Okay, it has been named as Lex YYC. So the program Lex YYC consists of a tabular representation of a transition diagram constructed from the regular expressions. Okay, regular expressions of Lex1. Okay, so together with the standard routine that uses the table to recognize Lex symbol. Okay, the lexical analysis phase reads the character in the source program, and it would then group them into a stream of tokens. Okay, in which each token would represent a logically cohesive sequence of characters. Okay, so such as an identifier, a keyword, a punctuation character, or a multi-character operator. Okay, so these character sequencing forming would form a token, which is called the lexeme for the token. Okay, lexeme for the token. So the actions associated with regular expressions in Lex A, okay, are pieces of C code. Okay, they are the pieces of C code which are carried over directly to Lex YYC. Finally, Lex YYC is run through the C compiler to produce an object program which is A out. Okay, so this is how lexical analyzer is created with Lex. Okay, so this is the process of. So now moving to the next one, that is the Lex source. Okay, so I'll just show you the general format of Lex source. Okay, so this is the general format of Lex source. So here, the definitions and the user subroutines are often omitted. Okay, so the second is optional. But then what happens here is that in the outline of Lex programs, as shown in the general format, the rules represent the user's control decisions. Okay, as seen in the table, in which the left column contains regular expressions. Okay, and the right column would contain actions program statements which are to be executed. Okay. So here, the absolute minimum Lex program will have no definitions and no rules, okay, which will later translate into a program which copies the input to the output unchanged, okay. It will copy the input to the output unchanged, okay. So this is the general format of the Lex source, and this is a sample input and output. Okay, I've just shown a part of the snippet. Okay, where you'll have to write a Lex program to identify if it is whether the input is given. Okay, and then the program will have to identify which are the digits, which are the uppercase, and which are the lowercase in that, and which are the variables. So the input, okay, the input is given as this is the input which is given. So the output is as such. So it has shown the number of uppercase, the number of lowercase, and the number of variables in the given output. Okay. So this is the sample input and output of the program. So in this session, we've seen the short introduction on what Lex is, what happens in Lex, and about the Lex source. And I've also shown you a sample input and output program. So I think with this session, you will be able to complete the objective by writing a Lex specification for token separation using regular expressions. Thank you.